Okay, well, welcome everyone to this meeting of the virtual IMS user group. Thank you for joining us. Lost my cursor. Right, there we are. Yeah, I'm Trevor Eddles. I'm CEO of iTech Ed Limited. We're a mainframe consultancy analysis and technical authoring organisation, and we're responsible for the content on the virtual IMS website, and we produce the newsletters. Just in case you've forgotten, our website can be found at itech-ed.com/virtual IMS. And we also look after the virtual CICS user group as well. So the agenda, as usual, most of the meeting will be taken up with a presentation. And today our guest presenter is Dusty Rivers. He's Director, Z Systems at Adaptigent. And his talk is entitled IMS as a Client in the New World. A copy of the slides from this presentation will be available on the website later today. And by the way, if you've missed any of our previous meetings, you can download copies of the presentation from our website. And you can listen again to them. There's a link on the resources page. So following Dusty's presentation and any questions you have for him, and yes, I think he'd like questions at the end, please. We'll move on to the latest IMS news, latest IMS related articles. I put feedback there just to remind me to ask you for your feedback about this virtual meeting. And then I'll give you the dates and times for the next couple of virtual meetings. So that's the plan. And I'm anticipating that the whole thing will last under an hour, maybe closer to 3/4 of an hour, something like that. Anyway, as I just said, today's presentation is from Dusty Rivers. Dusty is a well-known speaker at global events dealing with mainframe, IMS integrations and architecture. He's an IBM Lifetime Champion for Z, and a member of the Program Council IMGT at Share. He's over 44 years experience in IMS and mainframe systems. So Dusty, I'd like to thank you very much for being with us today. Oh, I meant to say, Dusty tells me he's coming from somewhere cold today, and you may hear him sneeze. So he has a little bit of a cold, but yeah, Dusty, thanks very much for being with us. Let me stop sharing and I can make you presenter. Right, you should be able to share your screen now, Dusty.
Okay. Thanks, Trevor.
You're welcome.
So you can see my screen now.
Yes.
So thanks for inviting me. As we were talking before we started, I'm Dusty Rivers. And what I thought we would do today is take a little different spin on the IMS presentation. I presented in the past on IMS APIs, things you don't know, things you should know. And so I'm going to take a different spin today. So the first thing I want to do is do a little bit of intros. And as Trevor mentioned, I've actually been working on IMS for 44 years. In June of this year, it'll be 45 years. And it's kind of an accomplishment that IMS has been around, functional, the backbone of major corporations for that long. And I was going to say I've been doing it a long time until I talk to people like Jim Martin or Steve Nathan or even Kenny Blackman, all of which Steve still says I'm a youngster because I've only been doing it for 44 years and it'll be 45 this year. And he accused me of going to the dark side at one time because I actually worked on DB2 for a while. But the idea is what I want to do is I want to talk a little bit about where we are today, where we're going, and also talk about real case studies. I find that sometimes when you come up with a concept or you talk about new technology, if you don't talk about what people are doing, it's kind of just vaporware or storyboarding. So the first thing I wanted to talk about, and Trevor asked me this earlier, is if I had talked to you this time last year, it would have said Dusty Rivers, Director, GT Software. And in about June of 2021, GT Software rebranded and relaunched as Adaptigent. And for adapting the intelligent enterprise, our product set at the time was being used worldwide by major corporations. And you would have heard me talk about Ivory Service Architect, or Ivory for short. And basically, that's our new website at the bottom, is that product is morphing into a more complete product called the Adaptive Integration Fabric. And you'll hear us use the word fabric. And what that's going to be is you're going to see a lot more activity, a lot more functionality, a lot more additions to that tool set. So I told Trevor as a joke, when I changed my profile, or when the company changed the profile, everybody assumed that I had left the company and gone somewhere else. It's just the company actually took on a new persona, and you're going to see some new exciting things, including, and I'm not going to announce, but I will pre-announce, there will be a major product announcement coming up next month. So watch this space. It'll be some new and exciting technology. But the idea is you're going to see new things. And today I'm going to be talking, I may intersperse the words ivory and fabric because I haven't been completely retrained yet. When you get to be old, sometimes it takes a while. So I wanted to throw this out there because I was at a Gartner meeting a couple of weeks ago, and someone was talking about this brand new technology a couple of years ago, and they were talking about the application server. And this is actually a definition from Gartner of their definition for what an application server is. And Steve, Nathan, and I, we use this a lot because if you see the second paragraph, and I didn't copy the whole thing, what is an application server? It's a high-end online transaction processing application that delivers business applications with guaranteed levels of performance, availability, and integrity. Uses multiple application design patterns. It also supports multiple programming language and deployment platforms, and it's highly scalable. And so what I said this, and actually Steve has said it several times, if anyone asks you and tell them to talk to me or talk to Steve, IMS was the first application server. Over 50 years ago, the concepts that are used are the same that new application servers are using today. So I would argue that IMS itself is, it's been around for 50 plus years, it was the first application server. So let's talk about the IMS, the one we know. Today, if you think about it, and when I started eons ago working for IMS, and again, I'm going to kind of use IMS DB and IMS DC or Transaction Manager, or however you want to call it, it was the secure, reliable, scalable, resilient system that many corporations based the backbone of their enterprise on. And it's been around for 50 years. If you think of over 50 years, if you think about technology today, what do you have technologically that works for 50 years? I know my iPhone, I have to get one every couple of years. My laptop, I have to get one every couple of years. And IMS has been around as the backbone forever. And then about, I would say 15, 20 years ago, there was the idea of, well, we need to get to the IMS applications. And we were doing, there were screen scraping applications, there were MQ applications, there were other ways to get in to IMS to expose them to new systems. But the idea of coming up with an API or an application programming interface, whether it was Corba or web services or REST or whatever the new thing is going to be, the idea was let's take the tried and true applications that we know and love on the mainframe, on IMS, and let's make them available to new applications. So you had, and I put them I use the cloud analogy here because I'm really talking about anything that is not on the mainframe, not in IMS, but we also have IMS applications talking to other applications and through an API also. But the idea is there were mobile apps. And if you think about it, when the mobile apps were created, uh, they're talking to applications that in some cases have been around for decades. You also have enterprise applications, new systems that are out there. You have web applications who they just want an API to talk to and they don't care. In fact, I would hazard to say that many of the applications they're talking to are probably older than they are. And then data and analytics. They're going after the mainframe IMS data, and they're going after mainframe applications in real time, going against systems. And most of the systems they're using through an API, they're not really thinking it's a mainframe. So what did we run into? And I actually, I'm not going to go into these a lot because I actually did an entire session on you don't know what you don't know. One we found out was the mainframe applications had things that new applications weren't worried about. And when you developed APIs, you had to worry about things like attributes, things like the applications on the mainframe in IMS were designed with a human being there. And so things like turning a value on the screen red or yellow or green didn't really apply if you're in an API. Also, we found out that if you're calling one transaction and it message switches to another transaction, which message switches to another one, that may cause you a problem. Also, maybe when you message switch to the second transaction, the output you got back was going to be different, including it could be multi-segment, multi-pages. It could also be variable length. It could be multi-part messages with different layouts. And these are all things we ran into. And the reason I'm telling you this is because when I talk about IMS being a client, you're going to run in these in a different way. Also different structures, language structures, COBOL structures, PL1 structures that maybe didn't map directly out into the new world. Also, and my favorite is we ran into this is in the old days when we used to care about how much message went across the wire on the screens, we used to use a null termination value for a field because we didn't want to send a last name of 25 bytes. Rivers is only 6 bytes. So we would put RIVERS, null terminate byte at the end. So we didn't send that across the wire. Well, those bytes don't exactly translate well on some of the new applications. Things like screen macros, where things were filled in on the screen and the transactions really didn't even know they were being filled in. Also conversations, things like IMS conversational programs, IMS conversational dialogues, they didn't really map well. Also, some of the other applications didn't map well. So the reason I'm throwing these out there is because these were all lessons learned. So I think Trevor has probably out on the IMS virtual user group, there's probably a session out there. I did one on you don't know what you don't know or lessons learned with APIs. These were things that we ran into that we had to get around. So let's talk about the title, IMS as a client, the one we're going to. And by going to, I'm talking about, we've already gone there. I mean, technically, a user today can submit a transaction, and because I'm not creative, I just called it Tran A, and that transaction needs to reach out to other information. And you may say, well, why do you need to do that? Why don't you just move that application, or why don't you just rewrite it, or why don't you just pick it up and do something with it? Well, a couple of examples of customers is in insurance, that transaction may be a tried and true insurance application, and the corporation bought a brand new rating engine that's running on a distributed platform, and all you need to do is get a rating quote. Or maybe you want to reach out and verify a credit card or verify a person's credit rating. Or you may want to reach out and see some new business rules as the companies adapt. There's some new business rules of ways of doing business, or there may be a payroll system that you want to reach out to. And I'll talk about a few of those that we're seeing today. And again, one of the things I was going to tell you is, as I go through use cases, these are active use cases. These aren't things that I'm making up to just say a nice presentation. We're actually working on these. So if you think about it, that IMS wants to reach out to all those applications. Now, things you got to think about. Most of the applications on IMS are written in COBOL. They're written in PL1. They're written in assembler. And the applications sitting out that you're talking to are written in Java, JSON. They're specified by WSDL specs or OpenAPI specs, different versions of OpenAPI, XML. And all of these data structures, all of these data formats, the protocols, you really don't want your mainframe applications in IMS to have to deal with those. You'd rather them just think they're calling out to something different. And IMS is so fast and scalable, you don't want to slow it down. So you have to think about, okay, how do I go from the left to the right? And that's kind of what we're going to be talking about today. So, if you're doing it at the utmost highest level, and I'm greatly simplifying this. So you need to be able to take the Open API, what used to be called a Swagger document, or a WSDL document, Web Services Description. You want to generate some stub code, basically where your COBOL PL1 programmers think they're calling another PL1 or COBOL program. You want to add that to the program, and then you want to be able to do that today. Well, how do you do that and make it easy to do that, and make it conform to the scalability, the resiliency, the security that you're used to with IMS? So what you want to do is kind of what I described to begin with, is that transaction has some stub code you're going to plug in. It's going to go through an API process or a server, and it's going to talk to all those. So on the right side, it's going to handle the interpretation or the conversion. I hate to use the word marshaling because that has other implied ramifications. But on the right side, you have the idea of things in Java or Node.js or new applications, and those don't quite map to COBOL PL1 or assembler. So you kind of want to be able to, and for those of you in the technology world, you may remember something called a babel fish out of Hitchhiker's Guide to the Galaxy, is you want both sides communicating without either side having to speak the language the other side knows. So you want to have a kind of a common goal in the middle of, I'm going to make an API request on the left side in COBOL, that the right side you're talking basically out via Open API spec or Java. But you could also have something like this, where, and we have a customer that's doing this, is in the bottom left, the red line, is you see the user making a normal request to transaction A. Transaction A actually is going to jump down, talk back through the API server out to the web and come back. And I'll give you examples of where customers are doing that today. So not only do you have the right side talking to the left side, you have the left side talking to the right side, and it may be going and talking to other systems. So the idea is today, the mainframe IMS applications are just another client in the new world of doing things. So the couple of things I was going to talk about, we have customers today, they're from their IMS system, they're talking out real time, getting printer information. We have customers that are talking real time to SAP. We have one customer that they get an order in on their mainframe IMS system. They immediately reflect an API that updates that order out on an SAP system real time. We have applications, and myself and one of the other engineers here actually wrote an application because we needed to get information out of Salesforce. And Salesforce has an API layer. Well, back when the application on the mainframe was created, there was not an email line, because at the time email wasn't a thing, but you want to get customer information. So you pull information off of your mainframe IMS customer record system, and then you reflect that ID, make a real-time call to Salesforce, pull the applications back in. Now, a couple of the next ones I'm going to talk about, AWS, Amazon Web Service applications, also streaming apps like Kafka. I'm going to talk about those in detail on another slide. But really, if you think about it, IMS through the APIs can talk to anything that's got an API. And I've said anything, it's like, it's very easy to do. We have customers doing it today. And I'll talk a little bit more about those other items now. So, if you're not familiar with this, you will be shortly, because many customers are being asked, hey, can I stream data from the mainframe? And I actually stole this slide off of the AWS site and I superimposed Kafka. Kafka is the open source streaming application. Kinesis is Amazon's implementation of that. But the idea is you want to pick up information real time as it's updated in an IMS system or on a mainframe, and you want IMS to participate in the stream. You said, well, that sounds really hard. Actually, it took us probably 15 or 20 minutes to pull down a streaming API, create a program, and make that call. So the answer is, can IMS participate in streaming applications? The answer is absolutely. Sorry, I had to take a drink there. As Trevor told you, I've got a little bit of a cold, so the voice is going to hold out. So how do you do that? Well, if you think about it, using my paradigm that I had before, is the applications in IMS, whether IMS is triggered by an event, or you've got a BMP running that's basically just saying every 5 minutes, I want to suck some information off of IMS database. I want to call an API and I want to publish it to the stream. And again, I don't care what stream, whether it's Kafka or whether it's an open source stream or whether it's a Kinesis stream, I don't really care. Also, since we were talking about AWS, there's applications that are running out on AWS that need to get to IMS, and IMS needs to get to them. Same scenario is basically, if you have an API, you can get to it. So with AWS or any cloud-based application that needs to get to and from your IMS system on the mainframe, it's as simple as finding the API, generating the artifacts, and making it immediately available. Takes not a lot of time at all. So a couple of considerations, and this is lessons learned. And I think one of our VPs here at Adaptigent, he said basically all of us who've been in technology a while are about 80% scar tissue, because we learn by things that bite us or things that we run into. So what I wanted to talk about now is, make this sound really simple. Hey, you can do this and it's not a problem. What do you need to worry about? Well, the first thing you need to worry about is, if you think about, you've got a transaction that's running inside of an IMS message region that's going to make an outside call to a third-party piece of software, that region is going to be blocked during the duration of that call. So you probably want to set up what I call an API region, and you want it basically with a different message class sitting over to the side that says, okay, these MP regions, I want them just sitting over to the side. I don't want them interfering with my normal workload. So you want to segregate those out. You want to put those in a region by itself that will not tie up other work that is critical. I mean, this is critical work, but that region is going to block for a while. Second thing is, think of the payload size. I mean, one of the things I found out is, we as IMS systems programmers, developers, users, we think of performance and granularity. We want to make sure that we're only asking for as much data as we need. And in the case of like multi-segment data, we'll pass you back multiple segments. You can decide how many you want to use. You can decide what you want to use. But it seems on the distributed side, sometimes the mentality is, we're going to give you everything you could possibly want in one invocation, so you could get a massive amount of information back. So you want to think about that when you're making these calls out, because I've gotten a 3 meg message back before, and it's like, really, do I need that? I just asked for information about a policy or some information. I didn't need 3 megs of information. So you want to model the payload just to make sure. And then, as I mentioned earlier, on the inbound side, there's some data types from the distributed data that doesn't map well. Well, on the converse is, you have to figure out, when you're getting this information back in, things like sequences or arrays, how are you going to map those into COBOL or PL1? So, the software will does a lot of that for you. But again, do you really want to map an unbounded 30,000 row array when you just need 2? So these are not deal killers. These are just things you need to be aware of. The important thing is specify a timeout value. We all know in an IMS region, things are time critical. Well, we don't have control over the systems that are out there, what I would say outside of the IMS system. So we need to set a timeout values to say, okay, if I don't get a response in X amount of time, I want the API or the call to time out, because maybe that system out there is having a hard day. Maybe it's running on a small platform. Maybe it's not going to be performing well today, and you don't want to tie up your region, and basically lock your system down. So always think about what time can you stand, and again, consider the endpoint. By that, I mean, I did an implementation for one of these in Europe, and we were generating 100 events per minute, which in mainframe vernacular is kind of slow. The problem is the endpoint could handle one event per minute. Now, it doesn't take a math major to figure out what happened to the endpoint. If the mainframe IMS system is pumping out 100 a minute to a system that can stand one a minute, you kind of need to figure out, okay, there's something wrong here. Maybe they need to upgrade. So I would say consider the endpoint is always important, because in an event-driven system like an IMS system that's used to, thousands of transactions a second serving, tons of users, is you want to make sure that what you're feeding out there is going to be able to handle the load. So now let's get into some case studies. So I thought, the first thing we want to do is talk about real world case studies. And again, the names have been changed to protect the innocent. So I'll categorize these as a Swiss bank. So we have a large Swiss bank as a customer, and what they decided to do is, if you open an account with them, they were imposed by law to verify that that person or entity opening an account is not a known money launderer, terrorist, or known criminal. So there's a third-party system, and it's actually called WorldCheck. There's a couple of other systems that can do this. Is from their IMS system. In this case, it happened to be PL1. Anytime from anywhere, they wanted to come up with a way for all of their systems to basically make sure that Dusty Rivers is not a known criminal. And I actually got to see this in action. We actually went into a branch, and I tried to open an account, and from the web app, it's got a lot of nondescript information that comes out. It's really cool, but in one of the branch manager's office, they still had an old 3270 type application. He went in and said, I want to create an application for, my real name is William, but William Rivers, here's his information. And there was a little green bar message that came up at the bottom and says, William Rivers, it's okay for him to open an account. So we're talking real-time invocation, real-time availability, and talking to a third party. And again, you don't know where that third party system is. You don't know, they had to put in changes for, okay, I got to make sure the system's up. They've got some lifeline, some heartbeat, making sure the system is there. But these are real-time systems doing real-time customer data from their IMS system. They were able to do this really quick. And then also in their particular case, they had some legacy systems, and I say legacy, my definition of a legacy is code that you wrote yesterday that's working, but they're using both SOAP and RESTful APIs, or WSDL and OpenAPI SPECT. So the idea is they realized that once they wrote this, that some of their core applications needed this functionality. It was very easy to extend this to make sure that other applications could just call into these, so they didn't have to rewrite new systems to make this case for the other applications. So again, this is a real world banking example. IMS PL1 systems calling out real time to third party software on multiple times, many times a day. The next thing is an airline. The airline has been using APIs for a while. And just to give you a scope of these, they're running about 25 million APIs to their IMS system, to their API system a month, which are probably being reflected at about 100 million IMS transactions a month. And these are all APIs, and they've got a great performance. And one of the presentations I did, I actually talked about a performance study where we went from the UI all the way to the database segment level and did a complete end-to-end performance study, and what we found along the way. And you'll be happy to know that there was absolutely no issues with IMS or IMS Connect or the IMS database or the programs or the API. Most of the issues we had in performance had to do with the hardware switches sitting out on the network. But the idea is what they realized is some of those applications, as I said earlier, they bought a new system. And that new system had third-party software that kept up with their printers. Now, you think, well, that's very nondescript. Why is that an issue? Well, if you've ever been in an airport and you're at gate 1 and the printer breaks and it won't print your tickets or it won't print the manifest, that's a problem. So they had to figure out, okay, where are other printers? And so from their existing IMS system, they had to call out to the printer inventory system and say, okay, I'm at gate 1. Where is an available printer that matches my printer specs that's available, that's not being used, and do it immediately and swap over and use that. So again, this was an IMS. In their case, it's IMS, COBOL, reaching out to a third-party piece of software that has no idea that it's being communicated with or invoked via an API. Now, the third one is a little different because it's a large French bank. And the French bank was mandated by the French government that they had to process real-time payments. By real-time payments, I meant if I'm going to send Trevor money, I call my bank and say, hey, I'm going to wire Trevor $20. My bank notifies his bank it's getting $20. They notify Trevor it's going to get $20. And probably tomorrow afternoon in Trevor's account, the $20 shows up. Well, they wanted to process this in a real-time mode. In other words, once I say I'm going to send Trevor $20 or $20 US, it's going to be in his account within seconds. So this is pretty important that it has to be done. It has to be secure. It has to be reliable. Well, in this case, it's an IMS system that processes that. So when it gets a transfer of money, it immediately calls out to a third-party system. It happens to be FIS's Clear to Pay that basically says, transfer this money immediately over to that bank. In this case, there's no take backs. So in other words, once I say I'm sending Trevor $20, it gets to him, it's in his account. I can't say, oh, I made a mistake. It's already gone. So it has to be secure. It has to be reliable. It has to be super fast because it's being done multiple times a day. And in this case, based on the French mandate, we actually working with them, we went from proof of concept to production in less than 2 months. We're actually extending this to other banks because of the mandate. And once they saw how easy this was. So, I mean, the first 3 that I talked about are real use cases that happen on a daily basis, multiple times a day. The third one is I'm going to talk about is an American bank. Basically, they're implementing their mobile applications using saving, checking, loans, credit, inbound. Well, they need to verify credit on the outbound too. So in other words, once if I have a particular brand of credit card, and I'm not going to name one because I don't want to slight any of the others, but if I have a particular credit card, they may be hosting that credit card, but if I have a bad credit or I own another credit somewhere, they need to make outbound calls from their systems out to a third-party credit verification system to verify these. So again, this is real-time application. So I've talked a lot. So if you think about it today, I'm working with customers that are basically including IMS in their real world. They're including IMS into streaming applications. They're including IMS into AWS conversations where AWS is calling in, IMS is calling out to AWS. And it's not just AWS, it's AWS and Azure apps, anything running in the cloud. Also, we're talking about banks. We're talking about manufacturers. And I left one out. It's a major car manufacturer that's also calling out to APIs, but I just left that out in the interest of time. But these are real systems that are running today. And these are not, trial systems. These are not things we're going to try to do a proof of concept. These are applications that we're doing today. So, my analogy is IMS is still rocking after all these years. And I use rock analogies a lot because I'm an old rocker and I like rock and roll. And so one of the things that, we talked about is anytime, it's funny to many of us who've been in the IMS space for years, is to hear someone say, yeah, but IMS is old. Yes, IMS has been around for a while. It's not old. It's been, much like our company, which is Adaptigent, talking about adapting. IMS has adapted from day one. It has added new technology, it's added new functionality, and it's participating daily in multiple new applications. And so one of the things, we're talking about, and you're going to see stuff coming, is when someone says, and I know all of us who are on this call, at one time you're going to say or be asked, or someone is going to say, hey, can IMS do X? And X being, it could be streaming, it could be queuing, it could be talking out, it could be talking in. And the answer is yes. So, again, I would also like to mention one thing as next month, as Trevor mentioned, I'm actually the IMGT program manager at Share. The Share conference is going live in person, face to face in Dallas. It'll be at the end of March. And, one of the things we're come by and see us if you're at the Technology Expo. We're going to have a booth there. We're going to be talking. We can demo a lot of this stuff. One of the things I didn't want to take time today is talking about, let's do a live demo. If you'd like to see a live demo of everything I'm talking about, of anything from creating the APIs, creating the artifacts, showing the artifacts, we can do that. Also, as a teaser, if you're coming to Share, if you're going to be at Share, come by and see us. I will in my back to my my rock and roll theme. We actually do our president does a show called Adapt or Perish on a rock and roll station. And as an incentive to come see us, if you're at Share and you write down the words adapt or perish, come by the booth, you'll get something extra. Also, just as a teaser, my email's at the bottom. If you want to talk to us at Share, or if you want more information about information I'm talking about, use the email at the bottom, and in the subject, put the words adapt or perish. We're working now. I know last time I did one of these a couple of years ago, we were going to send all the participants something, and customs and marketing had issues sending them out. We'll make it a little easier this time. So what I'd like to do now is turn it back over to Trevor to, I think I kind of kept it under 40 minutes. My goal was to try to get it around 35 to 40 minutes. So I'll turn it back to Trevor for questions now.
Yes, I think you achieved your goal. Well done for that, and well done for the rest of your presentation. If anyone's got any questions, then if you want to type them into the chat, then I'll ask Dusty. Just looking at the chat. Yeah. We did have one earlier, which I didn't interrupt you, where someone asked, is OpenAPI the same as REST?
So, OpenAPI, if you think of REST is an architecture. So RESTful APIs are an XML dialogue or architecture of representational state transfer. The way messages are defined or APIs are defined in using the RESTful architecture used to be something called a Swagger document, which is nothing but an XML document. Some people will call it JSON or JSON. And it specifies, what the data is in and out. Well, the Swagger has morphed into OpenAPI. And so you'll see most of the RESTful architecture APIs described in something called OpenAPI versions. So like OpenAPI version 1, 2, 3, and it's always morphing. So it's kind of analogous to in the web services world. There was a web services, there was a SOAP message that was defined, and the way you specified the SOAP messages was something called WSDL, which is Web Services Description Language. The way you define the messages is in the OpenAPI definition.
We haven't got any other questions come up. Let's just wait a moment in case anyone else is typing something in after that.
Yeah, and if anyone has a question, you had my email at the top, just shoot me a question. I'll be glad to answer it offline if you think of it when you get off.
Yeah, or you can send them to me and I'll pass them straight on to Dusty, and I'm sure I'll get back to you fairly promptly. All right, well, I will move on then. Let me just see if I can make myself presenter. Let's share my. There we are. Okay. So I promised you IMS news. Oh, sorry, I meant to say thank you very much, Dusty. I meant to say that because we're a virtual group, as usual, picture that you're getting a virtual round of applause. Sorry, thank you very much, Dusty. No, that was good. Right, moving on to news. I haven't got any, but from what Dusty was just telling us, maybe I'll have some for the end of March. Is your announcement going to be linked to IMS that we can include it in our news section, Dusty?
Yes, it will encompass IMS. Yes.
Yeah. Okay. You don't need to say any more than that. Brilliant. Okay. Yeah. So hopefully next time we'll have some news. And the other thing is, I couldn't find any IMS articles. There hasn't been anything in the usual places since November, so we haven't got any articles. The year hasn't started with a bang in terms of news and articles. So, feedback requests. Yeah, let me have your feedback. Anything about this meeting? Anything you think we can do to improve things? That'll be great. My email address is on screen. So send it to me and let me know. There's also the Contact Us webpage you can use on our website if you can't remember what my email address is later. So let's move on and see what we've got in the future. So 12th of April, we've got Locke Tran, who's lead software developer at BMC Software, and he's going to be discussing how to use IMS log records to investigate transaction response time. And then moving on to the 14th of June, we've got Hayley Fung again, IMS product manager for IMS and Ansible for Z, and she's going to be telling us more about Ansible. Those of you who were here at the meeting towards the end of last year will remember just how interesting that session was. Oh yeah, I want to just mention the Arcati mainframe yearbook. The 2022 edition is now available. I know some people contributed to the user survey in it, but yeah, the yearbook is free. It contains the user survey, an up-to-date directory of vendors and consultants, a resources guide, a strategy section with papers on mainframe trends and directions. There's a glossary of terminology and a mainframe evolution section. So that's all free. You can get that from itech-ed.com/Arcati. And it's a PDF. Yeah, just a reminder, you can keep up to date with what's happening in the world of IMS and on the virtual IMS user group website by following us on Facebook and Twitter, or by joining the virtual IMS group on LinkedIn. The URLs are on screen, but they're on the front page of our website, which makes it easier. And if you are tweeting or anything, then our hashtag is #virtualims. You may wonder why I've put YouTube there. It's just that if you get 100 people subscribing to a YouTube channel, you can actually rename it to something sensible. So you get a vanity URL with it. And we're about halfway there at the moment. So if you do click on the link on our website to look at the replays of any of these sessions, if you can follow us, then that will, well, subscribe, I think is the word for YouTube. That would be great, and we can then have a sensible name. Okay, well, that's all for this meeting of the virtual IMS user group. Can I thank you all for attending? Thanks to Rocket Software and BMC Software for sponsoring our user group. And of course, I particularly want to thank Dusty Rivers for today's presentation. So that's it. Thank you all very much for joining the meeting, and I look forward to seeing you again on the 12th of April. So thank you and goodbye.